Hello everyone, welcome to this second video on the note-taking guide. We are starting on page 2 of chapter 1. So the first topic here is Pythagorean theorem. Okay, many of you might remember this from your high school studies. If you have a right angled triangle, okay, so the triangle that you have here is a right angled triangle. Remember, otherwise it does not work. Okay, this angle here has to be 90 degree. If it is a right angle triangle, then this relationship is true, right? The two legs, we say, the two legs of the right angle triangle, A and B, if you square them and add them, A square plus B square will be equal to the square of the hypotenuse. So in the in-person class, we had this discussion. So let me briefly repeat it here. If this is a square on this leg, I'm for lack of space, I'm drawing like a rectangle, but assume that it is a square. Okay. And similarly here, let's say now you make a square. Then the area of these two squares, if you add them, if you had two, let's say, pieces of cloth of those sizes, and if you know, like cut them and into small pieces and stitch them together side by side without overlapping, then you'd cover an area which is equal to this. That's what it means. Okay. Sum of these two areas will be equal to that one. Okay. Now, using this theorem, let's solve some problems here. Okay. If A is 14 and C is 50, what is the value of B? And its solution is very simple. Okay. If you want to go ahead and give it a try, like even before I solve it, please do that, pause the video and then look at my solution. But if you want to see me solving one, you can do that as well. I will first write the statement of the theorem. This is a very good practice. Okay. When you have to solve problems, you can always try to think of what is the formula I can use. First write the formula, then plug in the values that you know. So for example, here, this is 14, I know. And whatever you do not know, leave it as it is. That's B square. We need to calculate that. I'll leave it equals C is given to be 50. That's 50 square. Right. Now that is 196 plus B square, and that will be 25 with two zeros. And I want to solve this in a reasonable space. So I'm going to zoom out a little bit. I'm going to erase this for now. Okay, I'll put it back later maybe. And I'm going to go up here. Okay, continue there. You get B square equals 2500 minus 196. And okay, when you simplify that, it becomes 2304. And from there you get B equals under root of 2304. Now focus on this process. Okay. B square equals 2304. So B will be under root of 2304. If you use a calculator, you'll see that this will turn out to be 48. Okay. And that's your answer. That's our answer there. Okay. Now you can go ahead and do the next one. It involves square roots there. No, no. Give it a try. Okay, at least give it a try, and later you can check your answers with me. I'll solve them now. Again, I'll start by writing the formula as it is, and then I'll plug in the values that I know. I do not know A, but I know B is under root of 7. Then I put a square there, equals under root of 11, and I put a square there. Right? That gives you A square plus 7 equals 11. And that means A square would be 11 minus 7, which is 4. And that gives you A will be under root of 4, which is 2. So you can say, therefore A equals 2, and box it as your answer. Okay. You would have noticed that between these two problems, in the previous one, everything was an integer, right? 14, 48, 50. There is a word for that. When you get such numbers, like in this example, you had 14, 48, and 50. These kind of numbers are called Pythagorean triplets. Okay. And there are infinitely many such numbers. A fun fact in mathematics, it can be proved actually. There are infinitely such numbers, such triplets you can find, but not every number has to be so neat. The second example shows that two of them are irrational numbers, like root 7 and root 11, but the third side turned out to be 2, which is a rational number. So it is an interesting area by itself. So this root 7, root 11, and 2, we don't call them Pythagorean triplets, okay? So those are three numbers which satisfy the Pythagoras theorem. But the Pythagorean triplet, that terminology is if everything is a natural number, you know? Okay, that is one point. The second thing I wanted to discuss here is, you would have noticed when we took the under root sign, we did not write negative numbers here, which is generally we should do that. For example, if A square is 4, then I should write A is either plus 2 or minus 2, right? Plus minus 2. We did not do that here. Think about it. Why? We did not do that here because these numbers are supposed to represent the length of a triangle, right? We're talking about a right angle triangle in the context of Pythagoras theorem. And the length cannot be negative. That is why we took only positive roots. See, you have to be conscious of that. Okay, you have to remember that. Okay. Next, use that Pythagoras theorem to find the distance between 2 points here. Now, this graph can be a little bit misleading. The boxes in that graph are not like one unit, okay, which we normally think. That's not the case here. So just ignore the graph. Look at the coordinates. There is a point Q 6 minus 2 and a point P minus 7 4. We have to find two things. What is the distance, the length of that segment, and what is the midpoint. Okay. Now, if you want to find the length, the distance of that line PQ there, what we could do is we could drop this and draw a right angle triangle, right? And now you will notice that if this point was x2 y2, let's say, and if this point were x1, y1 in general, then this difference here would have been x2 minus x1. Think about this. Okay. So when you write those coordinates, x1, y1, x2, y2, the x1 and x2 are the x values, right? So if you go from like x1 here to x2 here, what is the difference? That difference is x2 minus x1, right? That tab. Similarly, the height. Vertically, if you see, your point P is here and Q is here. So from y1, you're going to y2. Okay, then what is the difference from y1 to y2? And you will subtract y2 minus y1, right? Um, you like because we are going to square it. If you, even if you write y1 minus y2 or y2 minus y1, it doesn't matter because you are going to square it in the formula. Okay, but you can be consistent with one of them. Since I wrote x2 minus x1 here, I'm going to write for this part here. I'll write here that will be y2 minus y1. Okay. Now, just by following the Pythagoras theorem that we did here, a square plus b square is c square. So according to that, what should happen? The PQ, which is the hypotenuse, like the c square, should be a square plus b square. Your a is y2 minus y1 square, and your b, the other leg, is x2 minus x1 squared, right? And then from that, you get this formula. Now, if you want to find PQ, this is PQ squared. If you want to find PQ, you take under root on the other side, and that is where you get that formula called the distance formula. Okay, so that is how the formula is obtained. And once the formula is obtained, it's very easy to apply. So in this case, the length of that PQ is going to be under root x2 is 6, x1 is minus 7. So for the rest of the problem, as I am solving it and explaining it, I want you to be paying very close attention to the way we simplify it. That is where many students make mistakes. Okay, so this calculation part is going to be very crucial. Please try to do it by yourself if you want, but otherwise, if you are following my video, watch and listen very carefully. So it is 6 minus 7 in parentheses. Okay, x2 minus x1. See how I have used the parentheses. That is very important. That is whole squared. Plus, then I have y2, which is minus 2, minus y1, which is minus 4, squared. Okay. And that gives you under root 13 squared plus minus 6 squared. By the way, how did I make it 13? 6 minus minus 7. Minus and minus will make it plus. So it becomes 6 plus 7 squared, So that is 13 squared. And minus 2 minus 4 becomes, both are minus, so you add them, but you put the minus sign, right? So minus 6 squared. I know some students might need some more refresher on this kind of basic algebra. If you are one of them, like for example, if you are one of the students who is struggling to struggling in the sense you are understanding, but still you might think that you might want to do more practice on these kind of problems, do please meet me. Okay, I would be happy to help you, but you will have to do many more such problems to get more comfortable with calculations, which is going to be very important skill. Okay. So that is 169 and that is 36. And if you add them up, you get under root 205. Okay. You can try, we had this discussion in the in-person class. This under root 205, we realized later that there is no way to simplify it further. Okay, but for some other numbers, you can take out some part of it and write it outside of the root, and what we call mixed roots, mixed radical. But for this number, it is not possible. Okay, but in general, unless like we ask you to specially simplify it, you can leave it like that. All right, that is the distance. Okay, moving on. The next question is to find the midpoint. And the logic of midpoint is very simple. If you are like going from x1, y1 to x2, y2, A here, B here, then your midpoint here, you would have traveled an average of x1 and x2 for the x part and average of y1 and y2 for the y part, right? That is what is the formula here. X1, x2 plus x1 divided by 2, y2 plus y1 divided by 2. So for our example, minus 7, 4 and 6 minus 2, the answer would be, sorry, 1 second, minus 7, 4, 6 minus 2. So 6 plus minus 7, x2 plus x1. What happened there? Oh, okay. I think something got erased. So let me write again. 6 plus minus 7 over 2, x2 plus x1 over 2, and y2 plus y1. 6 minus 2, right? Minus 2 and minus 7, 4. So y2 plus y1 over 2. That will be minus 1 over 2, 2 over 2, which you can write as minus 1 over 2, comma 1. Okay, that will be the midpoint. Okay. Then there is one more exercise. Give it a thought. Okay, before I do it, I want you to give it a try. So in this problem, you have a point A, 2 minus 3, and you are given a midpoint, minus 1, minus 2. And you are asked this. What is the point B? Okay, you want to pause the video and think about it for a minute. Do that. Now, here is the technique. Whenever you do not know some quantities, you can give them some variable names, right? Call it xy. Okay. Then the logic of midpoint is, I'll write that here. Okay. Since M is the midpoint of AB, we get, what do we get? 2 plus x divided by 2, right? The x coordinates, 2 and x for A and B. Take the average. Minus 3 plus y divided by 2. That's the average for y. The y coordinates will be equal to minus 1, minus 2. That is the midpoint. Okay. Now that means the x part should be equal to the x part. Okay, let me actually start there. Yeah. The x part should be equal to the x part. So you should get 2 plus x over 2 equals minus 1. minus 3 plus y over 2 equals minus 2. And you go ahead and solve it. 2 plus x equals minus 2, minus 3 plus y equals minus 4. So here we are learning how to solve equations. Okay, that is also an important thing to learn. I took the denominator 2, and when I switch it to the other side, it becomes multiplication, so 2 times minus 1 minus 2. Similarly, the other 2 becomes 2 times minus 2 becomes minus 4 there. Then you take this minus 2 and subtract it on the other side, plus 2 and subtract it on the other side becomes minus 2, minus 3 on this side, on the other side becomes plus 3. Right? Okay. Or let me not box this. I can actually write the coordinates and then box it. That's your answer. Minus 4, minus 1. Okay. In the next video, I will be going to the second part of this lesson 1, the domain and range of functions and intercepts. I'll pause it for now. Thank you.